All right, welcome everyone. It's exactly 20 past. I'm just going to wait another 20 seconds or so for the last stragglers to come in. I'm not going to be holding you hostage for the full hour, I promise. So we do have a little bit of space here at the front. So we can just take a deep breath. Are you enjoying the conference so far? Yes. Excellent, great to hear. Hopefully they caught that on the recording as well. They're all having a great time. So come next year. All right, so let's start. So yes, my name's Adele Carpenter. I'm a software engineer at Trifork Amsterdam. I spend most of my day building and maintaining Java and Kotlin applications for the educational sector, although more and more lately you will find me trying not to cause too much damage with React in the front end. So has anyone here seen a talk from me previously? Yes, couple of hands, excellent. So look, if you haven't seen me, that's absolutely fine. I'm a relatively newcomer, but for those who have, welcome back. And of course, thank you to everybody in this room for choosing to attend this session. And I do hope that you enjoy listening to it as much as I enjoyed writing it. So I have spoken before about rewrites, and I'll use the example of Lika, a junior engineer who has joined a team working on a large and aging Java project. And she's feeling overwhelmed with the sheer enormity and complexity of the project and feels that the only way out of her current nightmare is a rewrite. And luckily, she is surrounded by an awesome team, and they help her see that a rewrite or a port is rarely a good choice. So as a team, they decide that they're going to start to move the project forward by taking small and consistent steps in the desired direction. And I 100% stand by that talk and that advice, but it did get me thinking, is there ever a time when a rewrite is a good idea? And it turns out that this was a little bit serendipitous, because around that time I started thinking about this, my team and I were presented with this very question on a customer project. So to give you a little bit of a background on Trifork, we are a project-based consultancy, and the team that I work with are a little bit unique in that we have a product as well, the assessment delivery engine, or the exam player, and we deliver this to a small number of customers, each of whom have a custom implementation on top of the core product. So basically the core product can pass assessments that comply with a certain specification, play the assessment for the student or candidate. So it renders the questions, manages the time remaining, selects the next question, and calculates the result. So we have the product part, and the custom implementations are the project part. So recently, one of our customers, the one with the most custom of the custom implementations, they were starting to get a little bit frustrated with one of our applications. And if I'm completely honest, we shared that frustration. So I mentioned already that one of the key features of our product is that it selects the next question, and that seems pretty straightforward, right? You have a list of questions, you pick the next one, go from index 2 to index 3 in a list. Well, no, not in this case at least. So for this customer, we actually have a dedicated web service whose job it is to select the next question. And at the core of this service is an open source C++ service written by a top researcher in the field of automated or computer-based student assessments. Her profile actually says automated testing, but I think for this audience, such language is a one-way ticket to a misunderstanding. And the service that she wrote is an implementation of item response theory. So item response theory is a family of mathematical models in psychometrics, which is the science of educational and psychological assessment. The models of IRT are used to design, analyze, validate, and score assessments. And to make things a little bit more concrete, you can think of an item as a question with a certain difficulty, ranging from low to high. And then, as you would expect, an assessment is made up of a selection of items of differing difficulty. Now, the point of the assessment is to determine the student's knowledge of or ability related to the topic of the assessment. Now, in a standard assessment, everyone gets the same questions. And for the average student, some of the questions will be way too easy and some will be way too hard. For some students, all the questions could be too easy, and for others, all of them could be too hard, which makes the assessment kind of useless for them. So one of the cool applications of IRT is that you can estimate a student's knowledge or ability on the fly and then deliver a question that is at the right difficulty for them at that point in time. And this can make the results of the assessment much more meaningful. It also makes the assessment appropriately challenging and hopefully interesting for the student, as interesting as taking a test could be. Now, I want to make clear at this point that the C++ service written by the researcher was not bad. She will forget more about IRT and statistical validation methods than I will ever know. But we did have some problems running and maintaining this service. Because the service, while reliable and fast, was essentially a black box. We sent it data, and it sent data back. And we did not have the skills in our team to verify the results. We kind of just trusted that it worked and selected an appropriate next question for the student. Initially, there had been some simulation testing done by an external party, but we were no longer in close collaboration with them, although, of course, we could always get them on the phone. So adding features was just something we didn't do out of fear that we would ruin the validity of the underlying algorithms. And this was the key source of frustration for the customer, that the service, while useful, was essentially stagnant. Now, of course, in a pinch, we could call the researcher and have a chat with her, but she's a busy woman and maintaining this application is not her highest priority. Now, if we add on to this, the service itself was not a web service. Years ago, there had been a developer on the team keen enough who had written a wrapper around the algorithmic core, so we had 4 endpoints that we could call. But our only options if we got an error was to simply check our request and retry. Further, logging in the core model was non-existent. So in our example, if we had an item with an unexpected difficulty, which could be as simple as a typo, there was no logging to tell us what was wrong. And since the core model primarily dealt with integer arrays, in order to build the request, we had to translate all of our item data into those arrays, leaving our requests essentially meaningless. So if there were any issues with a particular item, it was almost impossible to figure that out. And because the service is stateless, we needed to send the entire item bank with every single request, which in some cases was up to 60,000 lines of JSON. Then if you did decide to be brave and open the code base, you were presented with code that was written in the language of the academic domain. So we had names like this. And let's go through them quickly. So, APAR, not too hard, A parameter. But what does that mean? Item difficulty, obviously. BPAR, B parameter. In real terms, that's item discrimination. So how well does that item help estimate the student's ability? CurSeg, current segment, not bad. Still not explicit enough for my liking. Theta, another one from academia. Theta is the ability of the student. So now that we know theta, what is your best guess for warm theta? Yell it out. Most recent? Maximum possible? It's actually called warm theta because warm was the name of the guy who proposed this method of estimation in a paper. Not because it's a close guess, although, it's an estimation, so it kind of is. And then we round out the list with cluster and category. Again, these are academic terms. In the team, we use the terms friend group and domain, respectively. So far, I hope I've made it pretty clear why the current service is problematic. It's a black box, it's hard to reason about and debug, and trivial changes take a long time and include a steep learning curve. So maybe not so obvious is what makes the service a good candidate for a rewrite. Does anyone have any ideas? What makes it a good candidate, potentially? Yeah? Excellent. That's basically it. So it's stateless. So it receives and returns data, so we don't have to worry about a data layer or front end. So yeah, minimal relationships with other things. It has a well-defined scope or footprint with minimal dependencies, and we only need to expose 4 endpoints to one service only. And it is a small part of the entire project. And this reduces the risks or potential downsides of a rewrite attempt. So this brings me to what, in my opinion, are the three most compelling reasons to entertain the idea of a rewrite. And personally, I would think that you would need all three, but you would want at least two. And the reason I'd like to have all three is because they each answer the question or address the question of should we rewrite from a different perspective. But first, I want to begin with a reason zero, because, well, we are developers, so we are zero indexed by design. But also because without a reason zero, then all the other reasons are irrelevant. Reason zero, there is a desire to functionally change the application. If an application is running reliably in production and there's no desire to change the functionality, then I would be hard-pressed to come up with a reason on why you would rewrite it. You might see some odd behavior here and there, and investigating that when that happens might be the bane of your existence for a day or two. But if those incidents are few or far between, and there's no desire to change the functionality of the app, then that's probably just a reasonable cost of running it in production. And as long as you can do the bare minimum to keep it running, like bumping versions when necessary, moving to long-term support versions wherever possible, the status quo is probably fine. And if this is the case, but you still want to rewrite, you probably need to dig down a few layers on why you want that. Because it's probably about you and not about the application at all. For example, you are just not comfortable being responsible for something that you do not understand well. So, on to the first reason why you might entertain the idea of a rewrite. And we're going to start looking at the current service as it is in the context of the team responsible for it. There are no small steps to be found. So I stated already that I 100% stand by the advice to focus on consistency over perfection, to take small steps to move your application forward in the desired direction. And there is a really big implication here, though, which is that the small steps are, in fact, small. So let's take the example of bad logging in my team's project, the one I mentioned earlier. A great quick win would be to add some logging, right? So in this case, given that we are a JVM-based team working on a C++ service, that would require running the project locally, learning how logging in C++ works, actually learning like a lot about stuff that the JVM abstracts away, like memory pointers, identify an appropriate library, add the dependency, learn how the dependency management works in C++, learn the basics of the build tool, pray that it runs again. And for some teams, maybe adding logging to this application is indeed a trivial change. But for a team that lives mostly in the JVM, you need to ask, is the steep learning curve worth it? And at what point does something move from being a small step to being a large undertaking? And I think it's a bit simplistic to say that adding logging is always a small step. And the same goes for other small steps, like improving test coverage, extracting methods, renaming, improving abstractions. Whether or not they're really small or not is up for you and your team to decide. It's not up to me or anybody else. But what I can do, though, is I can offer you some advice on how you might approach these discussions. And that is to be aware of your bias and look for evidence that proves yourself wrong, rather than having a wish and trying to prove that it's a good idea. And this will help minimize the impact of confirmation bias on your decision-making. For example, if you are currently feeling the pain of a legacy code base, you are likely biased towards rewriting the application in a way that is more familiar to you. And in this case, I would advise you to look for reasons why keeping the current application in production is a good idea. So ask yourself questions like, why should I keep the existing code base? What opportunities exist to improve it? In our case, being the skeptical Dutchies that we were the opposite. We really saw a rewrite as a last resort. So our line of questioning was more around what pain are we experiencing now that can only be resolved by rewriting or porting the application? Are the opportunities to improve the application really there? And how much work are they really? Is that really less work than a full rewrite given the makeup of the team? So this brings me on to reason 2 on why you might consider a rewrite, which looks at the team in the context of the organization. The skills are not in the team, and you do not wish to acquire them. So does the team have the skills to consistently improve the service? And if not, does the company or team wish to acquire these skills? We have already established that a small step for one team could be a big step for another team. So you could be forgiven in thinking that this reason is basically the same as the first. But the key difference here is the last part of that sentence, and that's what I want to focus on here. No wish to acquire the required skills. So this is about maintaining applications that were in line with your company or project's tech stack. And this is a completely valid reason to consider rewriting an application. And it certainly was a big reason for us. So at Trifork Amsterdam, when it comes to the back end, we are very much a Java Spring shop. And yes, that includes Kotlin as well. And we incorporate tools and technologies that are within that ecosystem, or at least closely related. And for example, we might do JavaScript and React if we're doing front ends. Of course, we are made up of individuals with different backgrounds, so there is some .NET experience, and if you go wise and grey enough, you will find some C++. But our bread and butter is Java Spring, and that is not going to change for us for this foreseeable period. We're a small company, and we run many of the applications that we build, so keeping the tech stack manageable is a strategic advantage for us. And that doesn't mean that every new service we write is in Java, especially if startup time, memory use, or application size are priorities. But it means that while we do believe in the right tool for the job, we also know who we are and what our strengths are. And we look for good enough tooling that is complementary to our existing stack. So I'm digressing a little here, but this also helps us avoid the pitfalls of resume-driven development. Considering a rewrite is a time where you really see RDD come out in full force if you are not careful. As the name suggests, resume-driven development is making design and tooling decisions with the primary goal of adding content to your resume. And it often manifests as wanting to play around with the newest tech, even if that technology is completely incongruent with the rest of your team or company's stack. So if you're considering a rewrite and your eyes light up at the possibility of doing something completely new with an unfamiliar but exciting technology, then that's a moment to just take a minute and ask yourself, do I really need a rewrite? Or do I just want a playground for new toys? Or to keep the analogy going, a kitchen for new desserts. So by now we've looked at the service in the context of the team, and we've looked at the team in the context of the organization. Now it's time to look at the service in the context of the entire application. The service is small and the scope is well defined. Or it can be broken up in such a way that this is true. So, earlier we considered whether there are opportunities to improve the current code base as it is. And here we are looking at the suitability of rewriting the application in deployable chunks. So this is about minimizing the risk of wasting resources building something that never sees the light of day. Now, in our case, the rewrite candidate was already pretty well defined. It was a stateless service that had a very small, albeit important, role in the context of the entire application. However, we still ended up with 3 deployable chunks. This absolutely was not a 3-2-1 Big Bang cutover. So if the application you'd like to rewrite is larger and more central to your system, then it's even more crucial to have a plan on how you will break the rewrite candidate up into deployable chunks. Having a small defined scope for your rewrite is crucial so that you can begin to see benefits of the rewrite project as soon as possible. Amongst other things, this reduces the risk of your project sponsors pulling the plug on the project. They can see benefits early. So back in 2004, Martin Fowler was the first to coin the phrase strangler application. And as an Australian, I find this really cool, as Fowler was inspired for this metaphor during a trip to Australia, where he encountered the strangler figs. You can see it on the right in this photo in the foreground. So strangler figs are a parasitic plant that seed in the upper branches of a tree, eventually making their way down to the soil. And in this process, they envelop the host tree, essentially strangling it, after which the fig remains in its spectacular glory. And a strangler fig application works in much the same way. So this image is based on one from Paul Hammett's blog, which is conveniently linked to from Fowler's original article. Paul's an ex-thought worker, contributor to Selenium, strong voice in trunk-based development circles, and branch by abstraction. But before we discuss the image, here's the QR code to Fowler's article, which you can take a picture of or go to while I take a sip of water. I have been told the QR code works, so just a thumbs up, or the previous attendees were lying. Okay. So Paul's blog also links to a couple of resources as well, including an excellent paper by Chris Stevenson and Andy Pulse. So the rabbit hole you can go down from Fowler's article is well worth it. So back to this image that we can see here, shows a simplified evolution of a strangler fig web application. While certainly harder in practice than in theory, essentially you rewrite a piece of the application and you run the rewrite alongside the original app until eventually all traffic gets routed to the new app. Now, taking this approach makes it possible to weave in and deliver new functionality as you go, which can really keep the stakeholders happy and to build trust in the project. And as an extension of that, it can help keep the rewrite project alive. Now, how you go about carving out a piece of your application to rewrite will depend on a lot of factors, and it might be hard to know exactly where to start. So you could potentially use a really handy concept from extreme programming called a spike. So essentially, a spike is an experiment to explore a possible solution to a new problem. And it's so called a spike because it is end-to-end, but very thin. So a spike can be functional or technical, but it's usually best to start with a functional spike. So identify a pain point for your users in the current application and build a proof of concept to take away that pain or tackle that pain point. Ideally, you would get this pain point from your users directly, and it's like bonus 1 million points if you do. But it's also perfectly fine to just have a member of your team to act as a customer proxy. Now, in our case, our users were the researcher at the customer, and together we decided that the first deployable chunk would be a number of APIs, so it would be possible to interact early on with the item selection models. So the final application would actually combine 3 internal steps into one endpoint, but exposing the internals like this meant that the researchers could query the model directly and run simulations and verify that the model did what they expected it to do. And if it didn't, then they could provide feedback. Now, delivering this value early, even though the application was not production ready, this was important in building trust and keeping the project alive with the full support of the stakeholders. Further, it provided us with invaluable information on how we could get our first deployable chunk to production and what the scope of that chunk would be. So, when the question came up in my team of, do we dare to rewrite, despite our strong bias towards not rewriting, when we considered these 4 reasons, the answer actually became pretty clear. And I'm happy to report that not long ago, we decommissioned the last instances running the old application, and we are 100% running the new application in production. Yes, I will pause for your applause. So I think that's a really cool milestone, and I'd like to share a little bit more about how we approached the project and what we learnt along the way. So the first step was an audit of what the current model actually did. So with many discussions with the customer, the audit included meeting with the researcher who wrote the original application, simply to learn more about what the app does and how it does it. And on the slide here is like a very brief version of that feature audit. And the audit was actually really enlightening because we discovered how many features the app actually had, and interestingly, that we weren't even using all of them in production. So for example, there was a feature called content balancing, and what that means is you have questions or items from different topics in the same item bank. Then you can make sure that you have an even number of questions of each topic or category shown to the student. So basically, the model would determine which category should be shown next, and then of the items in that category, which is the best fit for the student at this moment. But in production currently, there's actually a separate item bank for each category, so we did not need the content balancing feature. Now, the customer did express a desire to potentially use that functionality in the future, so we added that as a potential requirement for a later release, but we deliberately left it out of version 1. And this phase was actually quite interesting as we uncovered how powerful the application actually was, but also how little of it we were actually using in production. Because had we uncovered all of these layers and learnt that we were indeed using all of them, then this would have been a really, really good moment to go back and reconsider whether a rewrite was a good idea after all. Because do we remember point 3? The scope is small and well-defined. That's not just something that you think about up front. It's something you need to keep in your mind as you go. Because I think this is really a big trap for developers, especially if you've just joined a project, say less than 12 months ago. It's actually a little bit Dunning-Kruger. We start to understand just enough of the domain that we think, ugh, why is this so complicated? If we could just start over, simplify the data model, abstract that over there, use some newer technologies while we're at it, wow, then we could move faster and enjoy this project much more in the process. But the truth about many production systems is they are the way that they are for a reason. You are not smarter or more insightful than your predecessors. Sure, things evolve over time. Decisions made in the past may be suboptimal given today's context, but there is often much more to architectural or design decisions than what is immediately apparent. So I would say that if you do pursue a rewrite, treat the first phase as a discovery or feasibility stage, even if you are writing code already. Prepare yourself mentally to walk away if things turn out to be bigger or more complex than you expected. So after a few meetings, we had an overview of the features and requirements for version 1. And it was decided that while the service itself would be a drop-in replacement for the old service, the underlying statistical models would actually change. And this was for a couple of reasons, one of which to make the model more extensible in the future. So, for example, the old model used only one item quality, the difficulty, to estimate the student ability. However, under item response theory, there are at least 2 other parameters that you can use to estimate that ability. And the other key reason for the change in the models was, as I mentioned, that there were other features that weren't being used at all. So a combination of unused features plus a desire for future extensibility led the researchers at the customer to decide to also rewrite the underlying statistical models. And that decision impacted our approach to testing a little bit. So in the end, it was the role of the researchers to validate their model against the existing one. And what they did is they provided us a list of inputs and expected outputs that we could add to our testing suite. And overall, it was actually a really nice collaboration as we both analysed the application code from different perspectives. At Trifork, we looked through the lens of inputs, outputs, exception handling, edge cases. And at the researchers, they were more concerned with the mathematical models and the psychometric validity of those models. So when we at Trifork were ready to start the development on the application itself, we were provided a model from the researchers that was written in R and accompanied with mathematical notation. So this meant that the team members could work on understanding the model in a way that was most natural for them. Personally, I preferred the mathematical notation. It was a lot more natural to me and helped me figure out the R code. But for some of my colleagues, the opposite was true. And I want to clarify that when I say we were handed a model, really it happened in stages. It wasn't like the researchers sat in a room for 6 months and then were like, here, put this in production. The researchers were fully aware that we planned to use Kotlin, and they even did their own investigation of potential libraries we could use, and they discussed them with us. So now as for the reason that we chose Kotlin for the project, then I hope it actually is already a little bit clear why we made that decision. So as I mentioned earlier, Trifork Amsterdam is a Java Kotlin Spring shop. It's our bread and butter, is what we do. In my team in particular, we have a strong preference for Kotlin. Believe it or not, actually learnt to program in Kotlin. And in my opinion, choosing Kotlin or Java within the context of a Spring Boot application is really little more than a personal preference. Sure, your preference is wrong if you choose Java, but everyone is entitled to their own mistakes. And as for the choice of Spring Boot, the downsides of the framework, mainly the size and the startup time, were going to be a non-issue for us. It's a good enough choice in the context of our company and team. So, having made our language choice of Kotlin, and together with the researchers, we looked at the numerical packages available to see whether they would be a good fit for building the model. JetBrains had been pushing Kotlin for data science a little bit, so we knew that we had plenty of options. It was just a matter of figuring out what would fit. Two options that came up during our search were Multik and Smile. So Multik is a multi-dimensional array library, and Smile stands for Statistical Machine Intelligence and Learning Engine. So immediately Smile just seemed a bit overpowered for what we would be doing. However, Multik was a solid candidate. So at Trifork, we went back and we did some experiments. So what we found was that while Multik would do a fine job, it wouldn't add anything extra for our use case. So it did make light work of calculations in multi-dimensional arrays, which we certainly would be doing. But after a bit more consultation with the researchers, we found that the arrays in the final model would only be two-dimensional. This is a very important distinction because two-dimensional space is very straightforward. 3+ is where it starts to get tricky. Because another way to think about a two-dimensional array is as a list of multi-parameter objects. And I'll show you what I mean by that by going through an example in the next few slides. Then after that, we're going to nerd out a little bit on mathematics, because if you did read the abstract, that is what I promised. And it's going to be on a concept many of you have probably forgotten and potentially deliberately forgotten. But don't worry. I'll keep it light, I promise, and this discussion is just a nice way to give a little bit more context why we made the decisions that we made. So, diving into the example now, in Kotlin, we can simply define a data class of multiple primitive types. This is a trivial example using sales at a waffle store, just to keep the domain as simple as possible. The very first time I gave this talk, it was in Belgium, so it had to be waffles. I was going to change the example for a local audience, but I decided that it's actually just fun to blame Belgians for no particular reason. So if you don't like the example of waffles, blame Belgian. One of my favorite Belgians is in the audience, by the way. So let's just say we have two kinds of waffles for sale at your waffle store, Stroop and Belgian. So they're each for sale at a different price. And I know I just came for Belgium pretty hard, but that's my right as a Dutchie. So to be fair, I actually made the Belgian waffles more expensive because they're more delicious. And I know I am a traitor to my adopted country. I do hope that they let me back in. Anyway, after you have the data for each of your products, then you can define the weekend sales data for your waffle store as a list. Now, to upgrade this code a little bit, you could lean into the type system and define separate types for quantity sold of each day of the week, for example. And we used this pattern a lot. It means that you never confuse the sales for Saturday with the sales for Sunday during your calculations, as they are different types. The compiler will tell you right away if you try to use a Saturday value where you should be using a Sunday value. Now here, this distinction doesn't really matter as the price is the same on both days, but is this extra bit of type safety saved our butts more than a few times, also reduced our need for a few test cases as well. So to give you a more concrete example, the item difficulty and item discrimination in our model are both doubles, and they're used side by side in the code base to determine which item is the best fit for the student at a certain point in the assessment. And by declaring them as separate types, we could be confident when we were doing our calculations on the intended parameter, and we could therefore prevent some erroneous results, aided with things like debugging as well. So, back here now to our waffle example, and continuing on, you can then calculate the daily sales of your waffle store using this syntactically beautiful sum of function, and you end up with 105 euros of sales on Saturday and 94 on Sunday. Now, just for a quick comparison, let's have a look at how you would represent that in the Multik library. So the cool thing about Multik is that it allows us to use matrix notation. So we could speak the same language as the researchers. So we can represent the waffle store data in the same way, by first, in a different way, by first declaring the prices of the different kind of waffles in a 1x2 matrix. That's the 2 and the 3. And declaring the daily sales as a 2x2 matrix. So on Saturday, we sold 15 stroke waffles and 25 Belgian waffles. And on Sunday, we sold 20 stroke waffles and 18 Belgian waffles. And then we find what's called the dot product of the prices and quantities, multiplying the row of the prices by the columns of the quantity matrix, and then adding the results together. And in doing that, we come out with the same result as the previous method, 105 euros of sales on Saturday and 94 on Sunday. Now, you may have a different preference, but for our team, using the features of the collections library on a list of type-safe objects, as we saw in the previous slides, was much more natural for us than manipulating two-dimensional arrays and matrices, as you see here. If you prefer this, I'm willing to get into a fist fight. So, sure, this is way more lines of code, but to me it's much more readable, and it trends towards self-documenting. So indeed, it turned out that we could do everything with the Kotlin standard library, and the researchers' model written in R was written with that in mind. They still use two-dimensional arrays or matrices in their models, but we could easily rewrite that as lists of multi-parameter objects, and the experience that we gained during our experiments with the Multik library actually helped us a lot out here. Now, I want to move on to the last section now of the Super Nerd segment. I already lost one person, so thanks for sticking in. So let's move on to the calculations themselves. So knowing that we wanted to stick with the Kotlin library, the standard Kotlin library, when formulating the model, the researchers stuck to approaches that relied on just basic scientific methods. So in the end, there was nothing more scary than Euler's number and the natural logarithm. And the Kotlin math package had us covered there. So just a quick example as a little refresher. For some of you, this might be your first time seeing it. No worries. I said I'll keep it light. But I did promise some geek in the abstract, so we're going to go do it. So as I mentioned, this just provides a little bit more context to our technology choice. So this is Euler's number E, and it is the base rate of growth shared by all continually growing processes. And this gives it a role in many domains, from investing to probability to radioactive decay. And just like pi, it's an irrational number with a set value. So what do I mean by that? Well, in mathematics, irrational means that there is no limit to the number of decimal places that the number has, and that there is no repeating pattern in its numerical value. So to make it a little bit more concrete, I've written out e to 150 decimal places, and hopefully the first 3 look familiar to a lot of you. The other cool thing about e is that it is its own derivative. So what that means is that the gradient function of e is the function of e. And that's not pointless trivia either. That's a really important property that we were able to exploit in our model. Now, if we go just one level deeper now, we can see that the value of e is the limit of the following expression. So if you keep adding these fractions, as n approaches infinity, you get closer and closer to the true value of e. Now, the last tidbit of trivia before we move on, given the exponential properties of e, Euler used the letter e, simply refer to exponents, but one of those cool coincidences, like how Thomas Crapper is known for his work on toilet-related patents, the letter is just now associated with his name, E for Euler. So in terms of working with E in code, in most worthwhile languages, yes, even though I'm a Java developer, I would consider C# a worthwhile language. You get a convenient function exp, which is e to the power of the past value. So exp3, e to the power of 3, equals 20.08. And you also get the natural log function, which is the inverse of the growth function. So the natural log of e to power is approximately equal to 3. And this inverse relationship is another useful property that we were able to exploit in our model. So these two functions, combined with other basic stuff like pow, abs, like absolute value of, and square root of, so that's to the power of, absolute value of, and the square root of, that ended up being the core of our model. So really sort of basic kind of high school, early university math concepts, nothing more complex than that. So while the math was far from straightforward, by collaborating with the researchers, we were able to come up with a valid solution using pretty straightforward mathematical expressions, which meant that we could write the core model in a pretty clear and maintainable way with just the standard library, which I think is pretty cool. And it also validated our choice to pick the stack based on what was good enough tooling in the context of our team, rather than trying to find the best language packages for modeling item response theory in R, because they exist. So we're going to switch gears pretty hard now, all right? Fair warning. And the slide image will probably give you a bit of a surprise. What are we doing here? But trust me, it'll all come together. So, I want to shift our focus a bit now and just use the last part of this talk to shamelessly throw in some pictures of a cute dog while I reflect on taking my first steps into a leadership role as a junior developer. Now, one of the things I really like about working at Trifork Amsterdam is that we don't have fixed roles or titles enforced. We focus on the individual, and if there's an opportunity that matches your skill set come up, have at it. So even though I only had a couple of years' experience as a developer when this project came up, I ended up taking a leadership role in some areas. And spoiler alert, it had mixed results. So in my studies of civil engineering and economics, I actually did quite a bit of calculus and linear algebra, and I had some experience with packages like MATLAB and Mathematica. And I am by no means a mathematical wizard, but it's a solid enough background, and at the time it was the most maths experience in the team. And adding to that, I've been working with the customer for about 2 years, so my domain knowledge was pretty solid as well. And the planets had just seemed to align. So having suffered mega imposter syndrome for those last 2 years, mostly fueled by insecurities related to not having studied computer science, I jumped at the chance to show off my different skills that I had picked up along my unconventional path to becoming a developer. And I came to those first planning meetings with much enthusiasm and lots of questions like, what model do you want to use? Where do we get this number from? How do we go about solving for that parameter? Do you have a paper I could read? And to be honest, it was probably quite insufferable. But just like a excitable puppy accidentally knocking over a pot plant with a stick that is much too big for her, I got a bit of a free pass, and most of my questions were answered. And even though I didn't understand all of the answers all the way through, it didn't matter. I could get my head around the basics. We had a probability function, which we couldn't solve directly, but we could estimate iteratively with the boundary closure approach. As I already mentioned, the customer was kind enough to provide a working example in R. Now, R is not a language I know well, but given enough time and Googling, this is pre-ChatGPT, I could figure it out. And I also had access to the service that we were replacing. Again, C++, not a C++ developer, but by taking my time and annotating as I went, I could understand enough to ask the right questions, get the right feedback, and form a sound understanding of the domain. And it was pure joy for me figuring out how to turn mathematical formulas and R scripts into production-ready code. You know, the kind of joy you see in a dog when she plays with her favorite ball. Now, we're a small team, so in the beginning, it was largely my task to put the proof of concept together, and that worked for a while, until it didn't. And I was having so much fun doing what I was doing that I just didn't include as many people as I should, as early as I should. Now, don't get me wrong, the project was 100% a team effort, but the proof of concept of the core model was a pretty important chunk, and I kept too much of that chunk to myself early on. And I had documented some stuff, but what I hadn't documented was all those loose ends that were still in my head of exactly what needed to happen before we could go to production. And well, it was summer by now, so like a good European, I went on holiday. And I'm a firm believer that timing is everything in life, so yeah, you guessed it, while I was on holiday, external pressure started ramping up to pushing us to get the first deployable chunk into production. All those to-dos that were still in my head were only in my head on a beach in Greece. And I came back after what had been a chaotic 2 weeks, apparently. The worst part was that some of the main issues the team faced were like non-issues to me. Like, I felt awful. Like, sorry, guys. So yeah, that was a big lesson. Leadership is more than knowing what's going on and being available to answer questions. I don't like to assume that others don't know things. I know that my colleagues are smart as hell, and I don't want them to feel any other way. And I think this comes from my own feelings about my intelligence and my identity, because, like, if I'm not smart, then who am I? But that philosophy is ultimately unhelpful to others. If people get offended because you want to keep track of the details, well, that's on them. So definitely, if I had my time over, I would be proactive in keeping the lines of communication open in the team and setting an example by documenting everything as I went. Even if it's just brain dumping in a ticket, as my Uncle Fred would say, it's better out than in. And one final note on this, because I think it's important to hear, even if it's just from some rando on stage. Even though I made mistakes during my first toe dip into leadership, I am happy I did it. I learned a big lesson that's been invaluable as I organically take on more leadership responsibilities as I progress in my career. So I really want to make sure that you hear that message. If an opportunity comes up to extend yourself a little bit, go for it. What are some qualities or experiences that make you a good fit, even if you don't have any direct experience in that exact task? And who can you ask for support, either inside your team or outside of it? Speaking from my own experience, imposter syndrome never goes away, but you do get better at shutting it up. And the way that you get better is by proving to yourself that not only can you do hard things, but that you can dust yourself off and try again if it doesn't go to plan. So, to wrap up, let's revisit the title of this talk. Are rewrites always a bad idea? Yell out, what do you think? Excellent. So, I did set you up though, of course, because purely just based on the way I've posed this question, it has to be no, simply because there are no certainties in life. Sweeping generalizations are always wrong, at least some of the time. So, maybe the better question is, are rewrites generally a bad idea? And here I confidently give a resounding yes. But they can be a good idea sometimes. So, in this talk, I've provided you with the top reasons to entertain the idea of a rewrite. Ideally, all of them would apply to your rewrite candidate, but personally, I'd like to see reason 0 and at least 2 of the others. So, reason 0, so called because without this one, then all others are irrelevant. There is a desire to functionally change the application. If you're not touching the application anyway, and it's running reliably and securely in production, why does it need to be rewritten? On to reason 1. There are no small steps to be found. You've determined the application does require some ongoing development, but the code base is in a state, and there are no quick wins for your team to start improving it. 2. The skills are not in the team, and you do not wish to acquire them. In other words, improving the application requires a steep learning curve towards skills and knowledge that the company does not need or want. Finally, the service is small and the scope well-defined, or it can be broken up into such a way that this is true. This means that you can deliver value and get buy-in early, and the potential downside is small. Now, if despite the odds, you have determined that your application is indeed a good rewrite candidate, then you can start taking some small steps towards that goal. So, start by conducting a thorough audit of what the current application does and what you will be rewriting. Keep it small and specific, with a healthy air of skepticism. Stay humble while you do this. The app is the way that it is for a reason, so be curious, not judgmental. Treat the audit as a feasibility study. If there is more complexity or scope than you first envisaged, be prepared to label the project as not feasible and walk away. Yes, even if you have already started writing code. In our case, the application was more complex than we first thought, but a lot of that complexity was in unused features. The audit helped us make sense of this and to get to a bare bones 0.9 version implementation. Now, when it comes to the tech stack, make a good enough choice in the context of your company and team. Rewriting an application comes with enough risk as it is. Adding a new or unfamiliar technology into the mix is just adding another layer where things can go wrong. And add value to your stakeholders as early as possible. Don't be afraid to experiment. For example, scope out a functional spike related to a pain point for your users. Put it in their hands. What do they think? Lastly, don't be afraid to step up and do something scary, like rate this session. I can't promise you that it will work out the way that you wanted, but I can promise you that you will learn something about yourself. My name is Adele, and thank you so much for your time. And seriously though, rate this session, please. Thank you. So I'm here the next 2 days. I'm more than welcome you to come up and have a conversation, maybe initiate that fist fight. And enjoy the rest of the conference.